Hello class, welcome to lesson 1-6, which is all about relations. By the end of this lesson, you should be able to represent relations and interpret graphs of relations. So let's start with, there's quite a bit of vocab, but hopefully it won't be too bad for you. Coordinate plane. A coordinate plane is the plane containing the x and y axis. This should be a familiar sight. This is our coordinate plane, okay? The x-axis is the horizontal axis. So this is our x-axis. And then the y-axis is the vertical axis, okay? So our y axis. The origin is the point 0, 0, where the axis is singular, axes is plural, okay? So the point 0, 0, where the axes intersect. So this is the origin. And an ordered pair is a set of numbers or coordinates written in the form x, y. As you can see in the what I wrote for origin, 0, 0, that is an example of an ordered pair, okay? The x-coordinate, going down to our next vocab term, the x-coordinate is the x-coordinate which represents the horizontal placement of the point. The y-coordinate is the y-coordinate, which represents the vertical placement of the point. Okay, so x is horizontal, y is vertical. If you're in my classroom watching this or while you're working on your assignments, just look over at the window and you can see I have each thing labeled. I have horizontal, I have vertical, and I have the x and y axis labeled to help you. So in case you forget what horizontal means or vertical means, you can just look over there and use your resources. Okay, so relation. A relation is a set of ordered pairs. And if this doesn't make sense yet, that's okay. We're going to be doing examples using these things, okay? That'll help you solidify what these mean. A mapping illustrates how much of each element of the domain, is paired with an element in the range. Okay? The domain, because you might be wondering what that is, the domain is the set of the first numbers of the ordered pair so the first numbers of the ordered pair, that means that's going to be an x value, okay, so I'm just going to put an x by it. And then the range is the set of the second numbers of the ordered pair. Okay, so that's going to be a y value. An independent variable is the value of the variable that determines the output. Okay, your independent variable is going to be your x value, and your dependent is going to be your y value. A dependent variable is the value that is dependent on the value of the independent variable, okay? So the dependent depends on the independent. Your y depends on your x, okay? If you look over here to the right, what I just highlighted in green, that is an example of a mapping. I forgot to point that out when we were looking at mappings, okay? We're going to be making some of those today as well. Example 1, we want to express, okay, and then we have some ordered pairs, 2, 5, -2, 3, 5, -2, -1, -2 as a table, graph, and a mapping. Okay, so let's start with our table. We want to list our x and y's. Okay, so remember, our ordered pairs are always written in the form x, y. X comes first, just like in the alphabet. Okay, x comes before y. So we're going to write all of our x's. We had a 2, -2, 5, and -1. So 2, -2, 5, -1. Sorry, that was a terrible 5. Let me try that again. 5, and then -1. Now let's look at our y's. Our y's are our second number. So we have 5, 3, -2, and we have -2. And if we want to see what that looks like, unfortunately, on my screen, it's really hard to see any lines, so I'm going to do my best for plotting these. But on the smartboard, I can barely see the lines. So hopefully it goes all right. Then we have 2, 5. So I'm going to go 2 in the x direction, which is horizontal. That means left and right. Since it's positive, I'm going to the right to 1, 2, and then I'm going to go, I just want to see how far, ooh, that's all the way at 3. Okay. I'm just doing that to try to figure out where my lines are. So we have 2, 5, and then 1, 2, 3, 4, perhaps right up here. This is really hard when you can't see the lines. So we're going to say that's 2, 5, and then -2, 3, -2 for our x is going to go to the left. So I think it's going to be right in there. And then a +3, 1, 2, I'm going to say it's probably right in there. Okay, so then I have my -2, +3. Next, we have 5, -2. I'm hoping here's 5. Okay, and then -2, so I'm going to go down 2. And then we have -1, -2, -1, -2. All right, that one was actually pretty close. So that's all that I need to do for my graph. I just need to plot those points, okay? Now we need to do our domain. We need to do our mapping. So we have to list our domain and our range. So our domain, we have all of our x values. So we have a 2, -2, 5, and -1. Our 2, and then for our range, we have a 5, we have a 3, and then we have 2, -2. So I'm only going to list that one time, okay? You don't list repeat numbers in mappings. Our 2 goes to 5. Our -2 was the same as 3. And then our 5, -2, and -1, -2. So that would be my mapping, okay? So table, graph, mapping. Now part B wants us to determine the domain and range of the relation. So I'm going to write a D for domain, squiggly bracket, and our domain is our x values. So 2, -2, 5, and -1. Our range is just like what we have in our mapping, 5, 3, -2. Okay? So that is how you create a table, graph, mapping, and determine the domain and range. Your turn to try to express the relation as a mapping. Which one is correct? Hopefully you said letter C here was the correct answer. If you have any questions on that, be sure to ask and try this next one. Determine the domain and range of the relation. Hopefully you said the domain was -1, 3, 4, and 5, and our range was -2, 2, 3, and 6. Let's take a look at example 2 together. We have identified the independent and dependent variables for each relation. Remember, independent is the one that it doesn't matter what it is. Dependent is changed by whatever your independent is, okay? Student council is selling suckers for charity. Sound familiar? The more suckers they sell, the greater the amount of money they can donate. Okay, so we have two variables, right? We have the number of suckers that are being sold and the amount of money that is taken in from those suckers. So, which one would be independent? Independent would be the number of suckers sold, and then the dependent, because depending on how many suckers are sold, that changes how much money can be donated. So that would be amount of money donated. It's supposed to be a dollar sign. It's a little sloppy. All right, in part B, let's try to determine our independent and dependent variables. Generally, the average price of going to the movies has steadily increased over time. So we want to list our independent and our dependent. Okay, so our two variables, the price of movies, and can be a little tricky to identify this, but if you ever see time listed in a problem, that is going to be one of your variables, okay? Time is always, always, always independent. It doesn't matter how much you stare at the clock in math class or watch the bar at the bottom of this video, just, oh, I want it to be done. You can't influence time. It's going to take whatever amount of time it needs to in order to happen, okay? However, as the years go on or time goes on, the price of movies is going up. So that is our dependent variable. So price of movies. Okay, your turn to look at this first example and determine what the independent and dependent variables are. Hopefully for this first one, you said that membership dues is the independent variable. The number of new members is the dependent variable. And try one more. Hopefully for this one, you said the length of the side is independent and the area of the square is the dependent. If you have questions on either of those, be sure to ask either myself or a friend. Now let's take a look at example 3. We have the graph represents the temperature in Miss Johnson's classroom on a winter school day. Describe what is happening in the graph, okay? So as you can see, we have this graph. We have temperature on the y-axis and time on the x. Time's always going to go on the x, okay? Temperature, you can see it goes up, down, up, down, up, down, up, down, up, and then it goes down. What does that mean? How is that happening? Well, let's think about it. When I get here in the morning, my room tends to be a little bit cold. So what's something that I do when I get here, do you think? When I come in, I turn the heat on a little bit higher than what it was overnight. Okay, so as you can see, as I turn on the heat, it warms up. And then you guys all come into my classroom and it gets quite warm. So what do? We turn the heat off. It gets cold again, so we turn it on. And then off, on, off, on, off, on, off. All day. We just keep doing this cycle, trying to get it to a comfortable temperature in this room. And then overnight, it drops again because there's no one in here to adjust it. Okay? That is how I would describe what is happening in this graph. I'm not going to write all of that out because that'll take a lot of time for the video and that would waste your time. But you will be looking at graphs similar to this and you'll have to try to come up with a story for what's happening, what's causing those results in the graph. Okay? Take a look at this example and see how you do. Hopefully for this graph, you decided that Macy's speed increases as she crosses the length of the pool, but then decreases to 0 when she turns around at the end of each pool. So she starts at one end, she's going faster and faster, she reaches the other end, turns around, and then she increases again, and then she's turning around. She gets faster and turns around again. Okay? That is what is happening in this graph. If you have any questions at all, please be sure to ask. I'd be more than happy to help you. Have a great day.